Welcome to the Platform Engineering Playbook podcast, where everything you hear is built, reviewed, and improved by AI, by me, and by you, the listener. This show keeps me, and hopefully you, up to speed on the latest in platform engineering, SRE, DevOps, and production engineering. It's a living experiment in how AI can help us track, explain, and discuss the fast-moving world of infrastructure. Every episode is open source. If you've got something to add, correct, or challenge, head to platform-engineering-playbook.com. You'll find all the content and a link to the GitHub repo. Open a pull request, join the conversation, and make the playbook smarter. Let's get into it.
Welcome to part 2 of our 4-part AWS reInvent 2025 series. In episode 49, we covered agentic AI and frontier agents. Today, we're going deep on infrastructure, chips, serverless evolution, and Werner Vogels' framework for thriving in the AI era. But first, let's check what else is happening in platform engineering. BellSoft unveiled their hardened container images at KubeCon 2025. Here's the sobering context. Typical container images contain over 600 known vulnerabilities. Nearly half of all Java services currently contain CVEs that attackers are actively exploiting in the wild. BellSoft's solution? Hardened images with 95% fewer CVEs. They're built on Elpakita Linux, stripped of package managers and non-essential components. Immutable configurations that prevent runtime tampering, plus full software bill of materials for compliance auditing. For platform teams running Java workloads, this is worth evaluating.
And here's a critical read for anyone building CI/CD platforms. A deep analysis just dropped on why GitHub Actions might have, quote, the worst package manager, end quote. The core problem, no lock files. Every workflow run re-resolves dependencies and results can change without any modification to your code. Version tags like action/checkout at v4 are mutable. Maintainers can retag without warning, silently altering your workflow behavior. Research found 54% of composite actions contain at least one security weakness, mostly from invisible transitive dependencies. No checksums validate downloaded code, and failed job reruns might execute completely different code if force pushes happened in between. If your platform relies on GitHub Actions for trusted publishing to package registries, this cascade of vulnerabilities should concern you.
Speaking of infrastructure decisions, Proxmox just released Datacenter Manager 1.0 Stable. This is positioned as a VMware escape hatch, centralized management across multiple Proxmox environments, VM migration between clusters without manual network reconfiguration, and fleet management tools for patching and updates. It's built in Rust, runs on Debian Trixie with Linux kernel 6.17. For organizations looking to exit VMware after the Broadcom acquisition, this opens the floodgates. Now, let's dive into AWS reInvent. The infrastructure announcements were substantial.
Let's start with Silicon. AWS is building its own chip empire, and Graviton 5 is the latest milestone.
Why does custom silicon matter so much?
Control and differentiation. When you design your own chips, you control the cost structure. You can optimize for your specific workloads, and you create features competitors can't easily replicate. Here's the key stat. 98% of AWS's top 1,000 customers are already using Graviton. This isn't experimental anymore. It's mainstream infrastructure. And here's the business case. AWS claims up to 40% better price performance versus x86 for comparable workloads. That's margin you're leaving on the table if you haven't migrated.
What does Graviton 5 actually deliver?
192 cores. That's 3 times more cores than Graviton 4's 64. 25% better compute performance per core, 33% lower intercore latency, and a 5 times larger L3 cache for memory-bound workloads. The memory bandwidth is the sleeper feature. They're claiming over 250 million operations per second for in-memory workloads like Redis and Memcached. It's built on ARM Neoverse v3 architecture using TSMC's 3-nanometer process. The new instance types M9G, C9G, and R9G launch in 2026.
What are customers actually seeing in production?
SAP reported 35 to 60% performance improvement for S4 ASNA workloads, Atlassian saw 30% higher performance with significant cost reduction. Honeycomb, the observability company, measured 36% better throughput. These aren't benchmarks. These are production results.
So for platform teams, the question is whether their workloads are Graviton ready.
Exactly. Most container workloads compile seamlessly for ARM. The migration patterns are well established now. If you're not running Graviton, you're leaving price performance on the table.
Let's talk about AI training economics. Trainium 3 is AWS's answer to GPU constraints.
The challenge is that training large models is expensive. GPU supply is still constrained, and NVIDIA's pricing power is substantial. AWS is offering an alternative, custom AI chips designed specifically for training workloads. The strategic play here is vertical integration. AWS wants to be the most cost-effective place to train foundation models, and custom silicon is how they get there.
What do the numbers look like?
Trainium 3 Ultra servers deliver 4.4 times more compute performance versus Trainium 2. 50% cost reduction for AI training, that's the headline. 362 floating-point-8 petaflops per Ultra server with up to 144 chips. 4 times better energy efficiency, which matters for data center economics. But here's what's architecturally interesting. Neuron Link, their custom interconnect, eliminates 50% of network overhead for distributed training. EC2 Ultra Cluster 3.0 can connect thousands of Ultra servers, scaling up to 1 million chips total. That's designed for training frontier models at scale.
Who's actually using this?
Anthropic is using Trainium for Claude training, Metagenomi for genomics research, Rico for document processing AI, and Descartes achieved 4 times faster inference for real-time generative video at half the cost of GPUs. AWS also announced Trainium 4 on the roadmap, which will be NVIDIA NVLink compatible. They're playing the long game.
And there's an on-premise option now.
AWS AI Factories, complete Trainium-based training infrastructure for organizations with data sovereignty requirements. You can run AWS's AI compute stack in your own data center.
Now let's talk about Lambda. AWS just fundamentally changed what serverless can do.
Lambda Durable Functions. The traditional Lambda timeout is 15 minutes. Complex workflows required step functions. Now you can build stateful workflows directly in Lambda that run from seconds to 1 full year.
How does it work?
2 new primitives. Context.step creates durable checkpoints. Your function can execute some code, checkpoint the result, and if anything fails, it resumes from that checkpoint. Context.wait suspends execution and resumes when an event arrives. You can wait for human approval, external API callbacks, timer expirations, all natively in Lambda.
Can you give us an example?
Picture a data pipeline that fetches data, then waits up to 7 days for human approval, then processes the data after approval. In the old world, you'd build a step function state machine, handle the callback pattern, manage the state store. Now it's 3 lines of code with context.step and context.wait.
What use cases does this unlock?
Human approval workflows, long-running data pipelines, multi-day batch processing, event-driven orchestration. If you're using step functions for straightforward state management, Lambda Durable might be simpler. It's not replacing step functions for complex orchestration, but it eliminates a lot of boilerplate.
What else is new in Lambda?
Lambda Managed Instances gives you EC2 compute power with Lambda's simplicity. It's a bridge between serverless and traditional compute. And IPv6 VPC support saves you $30+ per month on NAT gateway costs. That's low-hanging fruit for any VPC running Lambda.
Let's talk cost optimization, database savings plans.
Up to 35% savings for serverless databases, up to 20% for provisioned instances. 1-year term commitment covers Aurora, RDS, DynamoDB, and more.
How does it work in practice?
You commit to $1 per hour spent. AWS automatically applies that commitment across all covered databases. It's flexible across database types. For most tiers, there's no upfront payment required.
Platform engineering angle.
This is an easy cost optimization lever. If your database spend is stable and predictable, commit today. Stack it with reserved instances where applicable. The ROI calculation is straightforward. Stable spend equals immediate savings.
Now let's talk about Werner Vogels, his final reInvent keynote after 14 years.
He opened by saying, quote, "This is my final reInvent keynote. I'm not leaving Amazon or anything like that, but I think that after 14 reInvents, you guys are owed young, fresh, new voices," end quote. Then he laid out a framework for thriving in the AI era.
The Renaissance developer.
5 qualities. First, be curious. AI lowers the barrier to learning new things. You can explore any technology in hours, not months. Second, think in systems. Architecture matters more than ever. AI writes code. You design systems. Third, communicate precisely. AI amplifies unclear thinking. Vague prompts produce vague code. Fourth, own your work. Quote, "Vibe coding is fine, but only if you pay close attention to what is being built. The work is yours, not that of the tools. You build it, you own it." End quote. Fifth, become a polymath. Cross-disciplinary skills differentiate. Breadth plus depth equals competitive advantage.
And he introduced a concept every platform engineer needs to understand.
Verification debt. AI generates code faster than humans can comprehend it. That creates a gap between what gets written and what gets understood. The gap keeps growing until something breaks in production.
So code reviews become more important, not less.
Exactly. Werner Vogels said, quote, "We all hate code reviews. It's like being a 12-year-old and standing in front of the class. But the review becomes the control point to restore balance." End quote. For AI-generated code, human review is the last line of defense.
The big question everyone asks, will AI take my job?
Werner's answer was, quote, "Will AI take my job? Maybe. Will AI make me obsolete? Absolutely not." End quote. If you evolve.
Let's wrap with key takeaways. First, Graviton 5 is the new default. 192 cores, 25% faster, and 98% of top customers already on Graviton. The ARM migration is no longer optional.
Second, Trainium 3 changes AI economics. 50% cost reduction for training. If you're evaluating AI infrastructure, Trainium is now a serious alternative to NVIDIA.
Third, Lambda Durable Functions simplify orchestration. Workflows that run up to 1 year. No more step functions for straightforward state management.
Fourth, database savings plans are easy wins. 35% savings on serverless databases. If your database spend is predictable, commit today.
Fifth, verification debt is real. Werner Vogels' warning, AI speed creates new risks. Code reviews are more important, not less.
Next episode, we're diving into EKS capabilities. AWS is now managing your Argo CD, Crossplane, and ACK controllers. Combined with 100,000 node clusters and natural language Kubernetes management, is this the era of invisible infrastructure?
The infrastructure decisions you make today compound for years. Choose wisely.
That's it for this episode of the Platform Engineering Playbook podcast. Every topic, transcript, and summary you just heard lives out in the open at platform-engineering-playbook.com, where anyone can suggest updates or add insights through GitHub. If you've got thoughts, fixes, or new ideas, open a PR. And if you enjoyed the episode, rate us on your favorite podcast platform. We're always shooting for 5 stars. While you're there, give the project a star on GitHub. It helps others find and contribute to the Platform Engineering Playbook. This podcast is generated by AI, reviewed by AI, me and you, a community of engineers keeping our craft sharp. Thanks for listening, and see you next time inside the Platform Engineering Playbook.